undergraduate student at the University of Vermont, and I have been studying the diet of American eels in Lake Champlain. So first I'm going to give a little bit of background on the American eel life cycle. So they start out in the Sargasso Sea, where they hatch and they transform into leptocephali, where they float along ocean currents until they reach the coast and go through different life stages from glass eels to elvers to yellow eels, which we have in Lake Champlain. And then before they transition back into silver eels and go back to the Sargasso Sea to spawn. So American eel populations are declining and they're facing many problems. As you can see, they're challenging to study because of this complex life cycle that requires different management across different life stages and many different habitat types. In addition, the barriers to migration, such as dams, can be harmful to eels for migrating in and out of different freshwater systems. Eels are vulnerable to overexploitation, especially at the glass eel life stage. And they're vulnerable to climate change at all stages, especially leptocephali, as they can be influenced by warmer ocean temperatures and changing ocean currents. So a little bit about eels in the St. Lawrence River Lake Ontario Basin. So as you can see, eels migrate up the St. Lawrence River through the Richelieu, and then they get to Lake Champlain. So this is a long journey, and they have to pass through 2 dams to get here. And once they are here, these are our study sites. We chose 5 study sites in Lake Champlain to replicate sites that were sampled in the 1970s. And why should we care about eels in Lake Champlain? So eels in Lake Champlain are very important for cultural, recreational, and ecological reasons. Eels are very important to indigenous cultures. They are interesting to see while fishing or snorkeling, and they have ecological value as they are both predator and prey in marine and freshwater ecosystems and can contribute to nutrient transfer between these ecosystems. In addition, eels from the St. Lawrence River Lake Ontario Basin contribute up to 19% of the spawning stock, because by the time the eels get to Lake Champlain, they're pretty old yellow eels already, and they're large fecund females, so by the time they're migrating back out to the Sargasso Sea, they're really important for the population. And there are also lots of knowledge gaps about eels into the lake, and I'll get into that more in just a minute. So there are many knowledge gaps about eels in Lake Champlain. I'm going to start out in the late 1800s. On the Richelieu River, the Champlain and the St. Ours dams were built, but they were very leaky wooden dams, and eels could pass through just fine. Okay. The battery is right low on this. Okay. As I was saying, in the late 1960s, the same dams that I was talking about earlier, the Champlain and St. Ours, they were rebuilt and refurbished to become much more modern, and they essentially prevented eel passage to the lake altogether. Then in the 1970s, we have the first diet study on eels in Lake Champlain. Fast forward to 1993, we have the invasion of zebra mussels. In 1997, we have the eel ladder on the Champlain Dam. In 1998, the commercial fishery for eel closes in Lake Champlain. And in 2001, the eel ladder and the multi-passage fishway was installed on the St. Ours Dam. And as you can see in the late 90s, early 2000s, as a result of the population declines that became evident since the 1970s, people really wanted to help bring the eels back into the lake. Then in 2003, we have the invasion of alewife, which many of you know quickly became part of many fish's diets, such as lake trout. And in 2005, Hydro-Quebec stocks glass eels in an attempt to increase the population size. And also in 2005, we have the first spotted rusty crayfish sightings in the lake. Okay.
Excuse me, sorry for the technical difficulties. difficulties. We have to find Sarah to log into her computer. We just need to put you into Let's hear it for Hannah. She's doing amazing.
All right, so back to where we were. In 2005, rusty crayfish were first spotted in the Lake Champlain Basin. Then fast forward about 20 years and we have our study. So in our study, we wanted to look at what are American eels eating in Lake Champlain? How has American eel diet changed since the 1970s? And are they consuming any invasive species? So we conducted the study using gastric lavage in an attempt to reduce mortality as American eel populations are declining, and we didn't want to add to that more. So for this process, we first anesthetized the eels on board after catching them via boat electroshocking. Then we used a thin tube on a syringe to flush water into the eel's stomach and retrieve diet contents. We repeated this about 2 or 3 times. Then we rinsed the mouth, checking for any remaining prey items. It's also important to note we were able to tell if we got a good or a bad sample, and a good sample would mean we could feel along the eel's stomach and there wouldn't be anything there. But a bad sample would be that we could feel tension or like a hard-bodied item like a crayfish or a mollusk, and those were much more difficult to extract, but we usually knew when we didn't get them. And the eels recovered and could be released afterwards. So for our sample collection, we collected 32 eels via boat electrofishing, and all 32 eels were lavaged in the field. And then 9 of those eels were kept for dissection to essentially ground truth the lavage process to see how effective it was to retrieve diet contents. So when we began analyzing diet, we took out the larger prey items and measured and identified them. So as you can see, eels were eating a wide variety of prey items such as alewife, sculpin, fish eggs, crayfish, zebra mussels, and even an entire rubber fishing lure was extracted from an eel. Once we took out all the larger items, we processed the samples with a microscope to look for smaller items and help with identification of those. So we were able to find juvenile crayfish, insects, tiny mollusks, fish scales, and more. But as you can see on the right, that's what a regular sample would look like, pretty crayfish heavy and very digested. So it definitely was difficult to identify at the genus and species level. Here are some other cool finds that we found. We found fish larvae, fish eggs, and crayfish eggs in an eel. And eels are generalist and opportunistic predators, and we wanted to display this by showing frequency of occurrence by prey-specific abundance for the prey items that we found. So we were able to see if eels were more specialists or generalists, if there was rare prey items or dominant prey items within their diet, and if variation was high between individuals or high within an individual. So when we put these points on the graph, we were able to find that crayfish were by far the most commonly occurring prey item, with almost 80% of our eels consuming crayfish, followed by fish, and insects, mollusks, and other, which is vegetation or a fishing lure, were not often consumed. And all these points are below the 50% threshold on the prey-specific abundance, indicating that they are not specialist. Eels are not specialists, and they do not have a dominant prey type. Although crayfish, we believe, was underestimated in our study due to the gastric lavage process not always being as efficient in extracting crayfish, and due to the degree of digestion in many of the samples, we erred on the side of caution instead of saying there were multiple crayfish if we couldn't solidly identify them. So eel diet has changed since the 1970s. In 2025, eels were eating more fish and crayfish, fewer insects, we had fewer eels with empty stomachs, and 82.4% of our eels ate more than one prey type. And as you can see, this is a big difference between the 1970s, and we found it was statistically significant. And it's interesting just to see how insects have declined and crayfish have increased so much. We also split our eels into 3 size categories. I would say small, medium, and large, but honestly, in Lake Champlain, they're all pretty large eels, and they all exceed the 300 millimeter threshold for piscivory. So we didn't find any difference in diet composition by size. That also could be due to our small sample size. We did see a bit of a trend with increasing fish, and crayfish were dominant in all size categories. And we found that gastric lavage is effective for retrieving eel diet contents. We sampled eels ranging from 561 to 890 millimeters in length. The max prey length we extracted was 172 millimeters, although this was the rubber fishing lure, which is not an intended prey item. So the largest actual prey item we extracted was about 130 millimeters, and this was an alewife. The average prey length was about 14 millimeters that we extracted using gastric lavage. And our lavage efficacy was 64%, but it ranged from 40 to 100% because we only dissected 9 of the 32 eels in addition to lavaging them, because we wanted to keep the additional mortality pretty low. So some of the eels, if we could feel crayfish in them, we knew we weren't going to get those out, and that's more 40%, but then other eels we got 100%. It's also important to note that only 4 of our eels out of the 32 sampled had empty stomachs after doing gastric lavage, so it does seem that gastric lavage is effective for retrieving diet contents, and it will be important for the future to look more into this as American eel populations are declining, and we want to minimize additive mortality as much as possible, while also learning more about this species that we don't know a ton about. So to conclude, eel diet has changed since the 1970s. Eels are eating more crayfish and less insects. Some invasives were found in eel diet, such as zebra mussels and alewife, but we believe the zebra mussels were more accidental, as eels are benthic foragers and often go along the bottom in rocky areas looking for probably crayfish or whatever they can find, and the zebra mussels just happen to be ingested as well. Alewife, we believe, was more of an intended prey, as we found them in multiple eels, especially our larger size ones. And gastric lavage was proven to be an effective non-lethal method for examining eel diet contents, which, as I said, will be helpful for the future, for future studies and learning more about them. And I wanted to thank everyone who has helped me on this project, my mentor, Dr. Stewart, and field crew member, Ella Klein. And I wanted to thank UVM and the Patrick Leahy Lake Champlain Basin Program for providing funding for this project, Ruby Ecosystem Science Laboratory members for providing input and helping me along the way, and a special thank you to Doug Facey, who conducted the study that helped inspire my study back in the 1970s, for helping along the way and giving me some valuable feedback. So thank you very much.